Okay, students. So in this video, we will be looking at some numericals of chain drive. So here is the first example. A duplex chain 10B is used to drive a sprocket which rotates at 1000 rpm. The driven sprocket rotates at 500 rpm. The average velocity of the chain is 6.5 meter per second, and the available center distance is 500. Find factor of safety, number of teeth in the driving sprocket, and number of chain links. So here you can see that we have this designation, and what else are given? So driven sprocket speed is given, and driving sprocket speed is given. The driving one is smaller in this case because it is rotating faster, 1000 rpm. So the driven one is 500. Okay, and you have the linear velocity given and the center distance also. So you have to find out factor safety, number of teeth in driving sprocket, and number of chain links. Let's find out. So here, yeah, sorry. So either you can calculate the pitch or you can get from. Okay. The braking load is 4540 kg. This is from data book. Oh, this is the page number and the table number where you have to look. Okay. So page 340 of your data book and table number 14.39a, where you will find this for British standard. And the next page will find change for American standard. Okay. So page 340 and 341. These are the pages where you look, okay, for change. Now the braking load for 10B, you will get it from data book as 4540 multiplied with 9.81. You can also multiply with 10, no problem. So this is the braking load in newtons. This is in kg, this is in newton. Okay, now for actually this part, power rating is not available directly in your data book. Okay, so you can actually there's a table in the textbook that 1500 book that for speed of faster shaft, that is 1000 rpm, and for this 10B chain number 10B, you get a power rating of 8.97. Since this part is not available in the data book, this power rating will be given along with the question. So if it is not given in the question, you can suitably assume that. Next is the power rating. Okay, this power rating is equal to, in this case you see again. Okay, so from the relation of power rating, which is equal to P1 V by 1000. This we have we knew previously. Just put the value of power rating here, and then the velocity is given directly, so you can get the tight side tension. So again, from this relation of velocity, right, that we have learned previously, velocity equal to ZPN by 60 into omega t. So here, Z is the number of teeth, P is the pitch, and N is the speed. Okay, that is the RPM. So here, uh, if we consider a driving one, so you have to you have to take the speed of driving one. If you consider the number of teeth for driven one, then the speed also should be for driven. So here we need to find out the number of teeth in driving sprocket. So we have taken Z1, the number of teeth in driving sprocket, multiplied by the pitch you have found, and is multiplied by the RPM, the speed. Okay. So from here you will get the number of teeth. To prevent something, so we take the number of teeth as odd number. Okay, so we take it as 25 nearby. Next, from speed ratio we can find the number of teeth in the other the driven one. Okay, so as we know, speed of I mean, this is the speed ratio, right? So speed of the it's a number of teeth in the driven one, or the bigger one divided by smaller one, will have the speed ratio as more than higher than 1. So this is 5000 by 500. The speed of smaller divided by speed of bigger. Okay. So this you have learned already previously. We have been using this relation. Okay, speed ratio relation. So this is Z2 or Z1 equal to 1000 by 500. So from here Z2 is equal to 50. Okay, because Z2, the bigger sprocket has to be bigger. Its number of feet has to be more. Now you can keep it 50, or you can, I mean, if it comes as 50 exactly, okay, you can keep it as it is, no problem. Because we are interested in keeping this as odd number. Yeah? Now, number 10, driving sprocket. Next is the factor of safety. We know from the it is given, we can find it out by dividing braking load by allowable tensile allowable tension. So it is actually right side tension. The braking load is this, and allowable tension we have just calculated 1380. So from that you get the factor of safety as 32.27. And this formula, you know, this is for number of chain links. So using this formula, you can get this formula in the database also. So A is your center distance, T is the pitch, and Z1, Z2 are number of teeth in driving and reverse sprockets. So by putting all the values, you get the value of this number of chain links as 100.99. Now we cannot make it 100 exactly. Because 0.99 is nearly equal to 1, so this is 101. Now the thing is, there cannot be even an odd number of links. Okay, now your answer comes as odd number 102. So you have to make it 102. So we'll write it as 102. But since our answer led us to 101 only, so 101 total number of links we will use plus one additional link that is weaker than all other links. This is called offset link. Okay, so we'll write it as like 101 links plus one offset link. This completes our number. Next, we have another numerical. A 6.9 kilowatt AC motor is connected to a centrifugal pump using a deflection 0. The driving sprocket rotates at 700 rpm. The multiple strand factor and tooth correction factor are 1.1 and 1.7. So factor of safety is 10. The factor service factor is 1. Find the average velocity of chain and number of teeth in driving sprocket. So in this question, we have a duplex chain first of all, and we have a driving unit 6.9 kilowatt AC motor. The speed of driving sprocket is given. Then values of multiple strand factor, that is K1 1.11 and K2, that is tooth correction factor, are given. We are also given with the service factor Ks, that is 1, and the factor of safety is also given. They are asking what is the velocity of the chain V, okay, and number of teeth, that is in driving sprocket is Z1. So let's see how to solve. So you have the power of a motor. That is the power transmitted is given. Okay, so 6.9. Okay, power transmitted. This is not the power rating. You have to calculate the power rating or get it from your database. So in this case, we can calculate the power rating. Power rating is power to be transmitted is the power of your motor. Okay, for this numerical, this is given directly. Okay, so whatever is the rated power of the motor, that is the power to be transmitted, or we can call it a rated power here. The power to be transmitted is the power of the driving unit. This multiplied by Ks divided by K1 and K2 gives you power rating. So all the values are given. 6.9 is the power of the AC motor multiplied by 1, that is the value of Ks divided by 1.1 into 1.7 gives you the power rating. Okay. Now you can get the pitch value from your data book, okay, and the braking load both from the data book. Pitch is this 12.7, braking load is this one 31194. It will be given in the data book in kgs, 3180 kg. You multiply with either 10 or 9.8 to get this in Newton. Okay, so now we have got this power rating, braking load, pitch. So using factor of safety, this relation, factor of safety is equal to braking load by maximum allowable tension. So factor of safety is given as 10. Braking load you have got. So we can find out maximum allowable tension, that is 3119.5. Okay. So just by using this solution. Now you are asked to find out what is the velocity, okay, and number of teeth, Z1. So using this power rating relation, this one. Okay. So power rating is equal to P1 V by 1000. This relation you can get the value of velocity. So power rating is equal to 3.66 equal to this value of P1, that is 3119.58 velocity divided by 100. So from here you will get the velocity of your chain. And finally, using this relation, velocity equal to ZPN by 16 to the power 3. You put the value of velocity, which is known, and speed of your driving sprocket is given. Driving sprocket speed is 700 rpm. So put all the values here. So this is the velocity that you have found just now. This is Z1 is unknown, pitch is 12.7 mm, 700 rpm is given 6 divided by 16 to the power 3. Okay. This 10 to the power 3 comes because of this 12.7 is in mm. So ultimately this velocity is in meter. That's right. So consistency is already given there. So by calculating this, we will get the number of bits as 7.91. We can actually take it as 9. Okay, 9 because it should be odd. Okay, here it is written as 8, but we should take it as 9. So let's take your nearest odd number. That should be 37. So this concludes your video here, and we have concluded the discussion, short discussion of the chain.